guys hear me okay? Great. Yeah, I don't normally need a mic. Hi, I'm Steve. Thanks for coming. I'm here to talk to you tonight about Pythonic programming, according to my first slide. In preparation for this, I tried to do some Googling and research and such about what different people consider Pythonic programming to be, and I didn't really find a coherent answer. You see a lot of one-liners, a lot of little snippets that people call Pythonic, but really I didn't find anything terribly satisfying. So I took the liberty of deciding what Pythonic programming is, and I'm going to tell you what I think it is. And in a nutshell, it's taking advantage of Python's strengths, as I mentioned up here, and also avoiding some of the things that it's not necessarily so good at. This could be a little incoherent because it is kind of just a barrage of points, but we'll see how it goes. I guarantee you'll get your money's worth. So one of the notions that is really important in Python is the notion of an idiom, as it is in natural languages. If you've ever tried to speak a language other than your mother tongue, you've probably experienced the whole notion of saying something that's a direct translation of the sentence from your mother tongue and having a room full of native speakers burst into laughter or look at you and go, what are you trying to say? The same thing holds for Python. There are many constructs that are normal in other programming languages that just don't work very well in Python. I mean, they work, they function, and as I mentioned in my last talk, there's a lot to be said for functional code. By functional, I mean working, but they end up being anti-patterns in Python. But before I talk about patterns and anti-patterns and things like that, the first thing I have to mention about Python is that there's a whole bunch of stuff just built in, if not to the standard library. There's the Python package index that has a whole bunch of stuff that people have written. There's the cookbook, there's Stack Overflow, there's Google, there's all of these resources out there where a lot of people have contributed a lot to Python. And the point of this is, before you write anything, go look for it first, because chances are somebody's done something, if not exactly like what you're doing, then something very similar, and it can be a really good starting point. There was somebody I was working with and trying to convert to Python a few years ago, and she was actually working remotely, and she had written this lovely piece of code that had a whole bunch of Python anti-patterns in it, but worse than that, it was effectively trying to rewrite what is the pretty print module. So I basically ripped apart her code and told her all the things that were wrong with it and said, and by the way, you should not have attempted to write it in the first place. So I'm sure I was really popular with her. So some core things you have to worry about in Python. Some good things, not worry, I guess. It's the notion that everything is an object, but there are two kinds of objects that you have to worry about. There are mutable and immutable objects. And you need to know what you're working with because it can have some pretty serious performance implications. And then the other thing you have to remember is that most of the work in Python is actually done at runtime. So a lot of things when you're coming from other languages where you have a compiler that's doing a whole bunch of work for you, there is a compiler in Python, but it doesn't do a whole lot. Most of the evaluation is done at runtime, so any efficiencies that you build into your code get executed over and over and over again every time you run your piece of code. So let's talk about some anti-patterns. So again, the notion that there are some things you should just avoid. Can't have a good Python talk without talking about the Cookie Monster. I don't know if you've ever seen the Cookie Monster, but he's this blue guy who has a voracious appetite for cookies, but he's not very efficient at the way he eats. In fact, most of what he tries to eat, well, the fact that he doesn't have an esophagus is a problem because he's a puppet. But even if he had an esophagus, most of the cookies end up on the floor scattered in crumbs, and he just makes a big mess, and he doesn't actually succeed in eating very many cookies. And what they never show you in the sketches is the fact that somebody must have to come clean up afterwards, and it's not him. In Python, we have the garbage collector that comes and cleans up for us, but when you're programming, you don't want to feed the garbage collector. You want to be as efficient as possible. So strings are the biggest problem that you have to worry about in Python. You'll see here in the first example, I've actually created the same string twice, and it's a short string, and you'll see it actually ended up with the same ID. That's kind of fortunate. Python does this thing called interning, where it keeps track of relatively short strings that you create to try and help you along with the efficiency problem. And that's a nice bonus. But if we get to strings that are only a little bit longer, you'll see how I instantiated the same string twice and got two different IDs. So the first one, I fed the garbage collector, I'm being the Cookie Monster. So this is something that in teaching people Python, people who have typically come from something like Java, will invariably do something like this in their code. And like I mentioned in the comment here, you're actually creating 3 strings and you're immediately throwing them away to build your 4th string, and you're doing that every time you execute your code. So a couple of alternatives to this. One is the triple quoted format. That is perhaps good, but it does have some drawbacks in that it follows your indentation and it actually inserts line feeds at the end, so this string will actually end up with the line feeds. If that's what you intended, that's great. If that's not what you intended, it can be a mess. My preferred way of building strings is something that is maybe not completely obvious from the documentation, but you can actually put parentheses around and just kind of list your strings out, and it'll actually build a single long string for you. So if you're trying to keep your code nice and tidy, which of course we all are keeping our code nice and tidy, this is a great way to build up strings. So I recommend good string 2 as the pattern to follow. More string fun. This has many things wrong with it. Don't ever do this. But I have seen stuff like this. You can, in fact, build strings like this. You are feeding the garbage collector. You're also opening yourself up to problems with this line continuation with the backslash. As I think Brian pointed out to me, if you happen to put a space after your backslash, Python won't interpret it as a line continuation, and then you'll be staring at your code wondering why it's not working when it visually appears like it should work. So you shouldn't do this. Internationalization, if you ever have to internationalize this string, it's going to be really difficult. This is certainly a better approach if you've been working with Python like me for a while and come from Python 2. This is kind of the natural way to do things. You can also use dictionaries to reference things, which is a clearer way of doing things. If you want to move to the newer construct, there's the format method of the string, and you can do some fancy things with it. I'm not going to get into details because I could spend the rest of the night talking to you about format and never run out of things to say, but I encourage you to go and have a look at it. It's worth checking out. Built-in functions. Again, the top 2 constructs are the kind of things that you see people coming from other languages doing on a regular basis. They realize that you can iterate across a file, but then they'll just start building strings or building objects by addition. And again, every time you're doing this, you're feeding the garbage collector. The thing you want to investigate is something that is perhaps, I remember when I first saw the join method on the string, I thought it was a little bit of a backwards way of doing things, to build a string by joining a list of objects. But once you get your head around it, it becomes a natural thing. It's one of those idiomatic things that you just, at first seem strange and after a while seems completely natural. And just for fun, I threw in some numeric ones so I could talk about the built-in sum function. Again, same idea, adding up a list of things. Many beginners to Python don't realize that there are many ways to get through lists of things. Again, people from a Java background, which is a lot of what I've worked with, will tend to think that you have to index your way into a string, and they'll write code like this. And you don't have to do this. And not only do you not have to do this, but this code will only work if you have a list. If you're working with something that's a generator, you know, some arbitrary function that's returning values to you, this is not going to work at all. This bottom way is the more Pythonic way of doing things, which is just to say for I in something, or for X in some list, do something with X. That's the natural way of doing things. Imports. Yeah, the top one can cause you all kinds of grief. If you try to import star from a module, you will get all of the things that that module has chosen to export or make available for import in your namespace. And sometimes that can have some unintended effects. The top one I did just for fun because there is an open object that gets imported as part of gzip. Well, what that will do, Python will happily let you do that, and it will stomp on the built-in open function. So all of a sudden your built-in open function is gone, and then you're now stuck with gzip's version of open. And it's not easy to get rid of. So if you really need something that is referenced outside of gzip, I recommend something like this. If the name gzip is too long for you and you want to make it gz, you can do that and then reference it this way. A ridiculous example, obviously, but there are some long module names where something like that comes into play. The other piece is when somebody decides to throw something as elementary as in the standard library, they decide to nest it a few levels down. I'm not sure why they do that other than to irritate me. I'm sure that was the rationale behind it. But you can do this, but it makes for very verbose code, and not only that, there is the admittedly small cost of doing a dictionary lookup for every element in between your dots. So that's your dictionary lookup, and then get to the parse method. A better way to do it is to import your something dot something dot something as something short, and then make use of that. Smaller code, more efficient. Good all around. Okay, enough of things to avoid. Let's talk about some things that work really well with Python. One of my favorite things in Python that I make use of on a regular basis is this special method that comes along with every object, the str method. So what I've done here in my little example is I've created an object at the top, A. Yeah, great naming conventions. Object A does essentially nothing other than let you assign a value to A. Object B simply subclasses off of A, but it includes a doc string, which is always good practice. Doc strings are good. And then C subclasses off of B and overrides the string method. So my little test code down here, what I do is I actually print the object A, or the instance A of object A, print instance B, and print instance C. And if you've ever tried printing one of your own homebrew objects, I don't know about you, but I find the results less than satisfying. So I'll show you what you get by default. This is the kind of thing you get by default. You get this main A object at something which doesn't tell you anything. B didn't do anything other than override the doc string, so printing out the doc was useful. And then when we get to C and we actually we just print the object, it actually goes in and evaluates the string method and prints it out for you, which is a very useful thing because then you can kind of introspect your objects. So I do use that on a regular basis. Another cool thing, I don't use this as much, but I have used it in the past. One thing you can do in addition to the string method, there's a whole bunch of these. There's basically one for every arithmetic operation in Python. The add is one that I've actually used, and if you override that method, you can actually add your objects together or if you define that you want to define behavior between your objects and integers or your objects and strings, you can deal with all of that. And then you can write arguably more readable code rather than in a lot of languages where you have to write an add method and call the add method and it looks different from the built-ins. You can make everything look like a built-in. Dictionaries are one of the really strong points of Python. What I'm going to illustrate here is a goofy little function at the top, a doubler, which actually isn't a doubler because you can tell it what you want to multiply by. So you can call it in kind of the conventional way here, just by passing arguments to it. But one of the things that happens when you get into more dynamic programming or more complicated programming is sometimes you don't know exactly what your arguments are going to be. So Python gives you a really nice way of dealing with this, which is to just define a dictionary containing whatever values you need. And then you can actually call the function with a double star reference in front of your dictionary, and Python will then pass the arguments in, and everything runs as you might expect. So that's kind of handy. So here I specify val, and here I specify val and mult. And then just for fun at the end, I show the fact that Python takes advantage of duck typing, which is as long as multiplication makes sense for the object that you're passing in, it'll actually work, so I throw in a string just for fun. More fun. Oh yeah, this. Crap, I forgot. What's the name of this pattern again?
Dispatch.
Dispatch, thank you. This is the dispatch. One of the complaints you hear about Python sometimes is the lack of a switch statement, or the fact that you have to kind of verbosely do things like this. So let's say you've got a list of functions, and you want to choose your function based on some input. I'm just choosing a random number here. You can code it like this, and this is clear and obvious what's going on, but it's not very Pythonic. There's another way to deal with it, which is kind of a reminder of the fact, as I mentioned at the beginning, everything is an object, including functions. And that isn't something that's necessarily clear to newcomers to Python, is the fact that you can actually reference one of these functions as an object, and you can simply execute it by putting open and close params after it. So I'm executing one of these functions randomly. I'm not sure which one because I didn't run this code. So I'm actually saying here in my dictionary, if the input is 1, this is the function. If it's 2, this is the function. If it's 3, that's the function. And I'm also taking advantage of, on a dictionary, the get method, which provides a default. So I can say, well, if it's not any one of those random numbers, I'm going to run my default function. So I'd love to use this in a piece of code somewhere. I still am waiting for the opportunity, but it is very cool, and it does illustrate the power of Python. So I guess that's the end of my points. Just remember, Python is different. If you work with other languages, sometimes the things that feel natural just aren't going to work so well. So the more you learn about how Python works, the better off you'll be. And just understand strengths and limitations. I guess one thing I kind of glossed over is the whole notion of style. Style is, writing things in a consistent fashion so that other people can read it is useful. That's the reference to PEP 8 on the top. That's sort of Guido's, here's how you should write Python, and Guido's a pretty smart guy, and it's probably a good idea to follow his recommendations. The special methods I talked about are mentioned in the data model. Again, I remember it's the first time I encountered them, it's like, where are they in the doc? Because they're not really anywhere obvious, but that's where they are if you're looking for them. Python Cookbook is a very good resource. Check it out. There's a Dead Trees copy. There's that website. Stack Overflow, I find, has some really good resources. Python Package Index, it's amazing the number of things that are in there, and it just grows every day. And if you don't know who the Cookie Monster is, you have to go go find out because he's great. He rocks. And that's probably not the best video of him. There's some other ones that are funnier, but that illustrates his cookie eating skills. And that's it. Questions? Comments?
One comment, if you're defining something to pretty print an object, it would probably make more sense to define repr instead of stir. Because repr will be used in more places than it's string. Like I just looked it up now. If you have a list and you print out a list of objects, it will print out the list of the representations of each of the objects, not string format of them.
Uh-huh. Repr better than string. That's a good point.
Repr can also be used to recreate objects. So if you, generally when you create reprs, you want to be able to almost run that code in Python again to get back that same object.
There we go.
So for the dispatch thing, there's also another weird solution if you have control of the thing that's returning the code. So in your case, you had random int 1 to 3. In some cases, you have control over the code's return. One way to avoid it is not to return codes at all. So if you refactor out the codes and refactor it into returning an object or a function that can be evaluated, then you avoid a lot of this slack case problem all around, as well as your dispatch is basically the slack case by default.
Right, right. Yep, no, it's a good point.
So, do you have a least favorite anti-pattern?
A least favorite anti-pattern.
And have you, if so, have you mentioned it in the talk, or is it something worse than neutral?
You know, the one that makes me absolutely crazy when I'm working with new programmers is the whole string concatenation thing. That one is just it's horrible, and especially the example of yeah, this one, doing this kind of string building. Or I guess, you know, iterating through something and building a string that way, you know, it's just, it really just indicates a complete lack of understanding of what's going on in the background. And you know, it's an honest mistake. It's you know, a lot of languages that's perfectly legitimate and probably the preferred way of doing things. But it is, I think it was in the Python cookbook where Alex Martelli, one of the authors, referred to it as the worst anti-pattern in Python, and yeah, I agree with him.
Are there any guidelines to default values of arguments in functions?
Guidelines for default values, yeah, there is one big one, which is do not use immutable objects as, there are certain objects that you do not want to use as default values, specifically because they only get evaluated once. So if you pass an empty list as a default argument, that list will start growing over time even though you don't expect it to. And you get some unanticipated behavior that way. So my rule of thumb is if in doubt, use none as your default value. And then when you need to pass in a string, the pattern, I guess, is, that's a good pattern, I should have put that in my talk. So rather than passing in an empty list, you would say your argument is none, and then the first line of your function is, if argument is none, initialize it to your list. And then you get predictable expected